Those of you that know me know that I'm probably going to be annoyed at myself for my title, purely because whenever you're doing titles, you should have capital letters for all the major words. So I started doing that for radioactivity, nuclear, and then for some reason I stopped. I should have done it for ionizing and radiation as well. If I'd written the word and instead of put the symbol, then the and would not have a capital letter. But we're not here to talk about the English language right now. We're here to talk about radioactivity and nuclear radiation. Sometimes you'll see them call it ionizing radiation, which reminds me, I'll need to tell you what ionizing means. Hopefully I won't forget to do that. So why are some atoms, why are they radioactive? Again, I know I've used, when we had the meeting, I already used this example, this analogy, but a lot of you did not turn up to it. So I'll use it again. So imagine I've asked you to, walk up 2-3 flights of stairs, carry some books for me to the top floor. You'd probably be like, yeah, I'll do that because you're nice, polite children. But what about if I kept adding more books? So at first you would probably just say, yeah, of course, miss, I'll carry those up for you without actually asking how many. Suddenly you got 30 books in your arms. Now, first of all, carrying 30 books is actually harder than you might think. If you're talking about exercise books, especially when they're laminated and they just slip all over each other. It's definitely way heavier than you think. If I said 60, then there's no way you could do that in one trip. So what would you say to me if I put 60 books in your arms? You'd probably be saying, miss, please, can you take some off? And if I was feeling nice that day, I probably would. In fact, of course I would, because I don't want the books going everywhere. So I would take some of those books off of you. And the reason is it's going to be harder to carry more books than you had originally. The more I put on, the more difficult it's going to get, the more likely that they're going to fall off, or that you're going to trip over or not be able to see where you're going. So basically you're in terms of the analogy, it's like a nucleus of an atom being unstable because it's carrying too much inside the nucleus. That's why you don't tend to see very many radioactive elements lower down in the periodic table, but the higher up, technically the lower down the periodic table you go, or the further along you go, it tends to be, you tend to see more and more radioactive elements. Most common examples are probably uranium, plutonium, and some others. So yeah, again, if you've got a periodic table in front of you, just have a look at their atomic mass numbers, and you'll see they're quite hefty. And so they want to remove some of that. So that's exactly what they do. So they can become more stable. They want to remove something from the nucleus. That's why it's called nuclear radiation. Now, there are 3 types, alpha, beta, and gamma. And there's quite a lot that you need to remember about these. So first of all, I should draw a table really, even though I can't remember all the things I'm going to put in the table. First of all, let's say name of nuclear radiation. And I'm gonna, name of nuclear radiation. There's only 3 types, so that should do. Next thing I want to say, symbol. Yeah, they all have a symbol. And that's not going to be a very wide column either. And then I want, do you know what, we'll get to it. First of all, let's just fill in this part of the table first. So the first one is alpha. Then we have beta. and then we have gamma. And so the symbol for alpha is the Greek letter alpha. It looks very similar to an A in the English alphabet, but it is not an A. Some students like to think of it as a fish, I suppose, because that's how you tend to draw fish when you're young, and you just complete that bit there, but obviously don't for the alpha symbol. Beta is the Greek letter beta. Again, looks very much like a B, a capital B in the English alphabet, but it's not quite. It's got a tail. Okay, so that's beta. And then gamma. A lot of people think it looks like a Y. I can see where they're coming from. That's gamma there. So those are the symbols. Now, what do you need to know? You need to know what are they made of, or what do they consist of? So let's add that column in. What are they made of? I did not draw that straight. So an alpha is a particle, very important. It's a particle. It's made of 2 protons and 2 neutrons. And it is equivalent to, I've not left myself much space, a helium nucleus. I'm actually going to have to cut this video short. I have an errand that I very quickly need to run, but the next video I'll start exactly where I left off, and I'll just recap on this bit here. Sorry.